All right, welcome to pre-lecture 4. In this pre-lecture, we're just going to be previewing chapter 4, looking at probability. So these are probably a lot of terms that you've seen before, some things that maybe you're already familiar with, but we'll go over them together here. The first is just what is probability. It's a way of representing the likelihood of something taking place, that we can identify an event, and depending on what information we have, we might be able to assess its likelihood of happening based on the information we have. It's going to be represented as a value between 0 and 1, or if we represent it as a percentage, it's going to be 0 to 100%. But get used to kind of this 0 to 1 notation. We'll use a lot of decimals like 0.233 as a probability. So just keep in mind we'll represent it as a decimal quite a bit. So here's an example where we have a drug test. We're looking at results of a drug test. So maybe if you're being employed by a new company, maybe you're entering an athletic competition like the Olympics or some other important competition, you might take a drug test. And so to kind of look at the effectiveness of this drug test, we had some people take it who we already knew had taken drugs that should test positive if the drug tests were behaving perfectly. But of course, with any test, including a drug test, it's not going to always detect with 100% accuracy somebody's status. If it's a good test, it's going to be doing a pretty good job of detecting that, but always with a few mistakes as well. So that gets us into some terms that we're going to see a lot in this class, and that's going to be true positive, true negative, false positive, and false negative. So think about true and false as meaning it's accurate or it's not accurate. So if you get a true result, that means that it told you the correct thing. It was an accurate result. False meaning that it was an incorrect result, that it was an inaccurate result for what you really are. Positive and negative. Positive means that the test says that you have the thing. So in this case, that you have drugs in your system. Negative means that the test indicates you don't have drugs in your system. It didn't find enough evidence of drugs in your system. So true positive and true negative mean that you correctly test positive, you correctly test negative. False positive and false negative mean that you got incorrect results. One saying that you had drugs in your system when you didn't. False negative meaning it didn't find indication of drugs when there really were drugs. So we have 555 people here who took this test, and we can see how many kind of fit in each category. Most of the people in this study were truly negative. They were individuals who did not use drugs. 480 of them got a correct true negative, but 25 of them got a false positive here. And then same, we have 50 people here where 45 of them, 50 were using drugs, 45 of them correctly tested positive, 5 incorrectly tested negative. We can see that again with the table here where let's see if this is correct. Yeah, so the orange here, this would be it would be a true negative. The blue here would be a true positive. And then this little slice and this little slice are the people who got inaccurate test results. So let's kind of learn some probability terms with this example. The first is just classifying possible outcomes. So we call this the sample space. We use it a lot when we're talking about categorical data, where we just want to identify all the different outcomes that are possible. If our variable of interest is numeric, then we could identify the sample space as like the numeric scale that we could see. But we often use this term when we're talking about categorical variables or just maybe discrete variables as well. So let's just consider one variable because we do have kind of two going on up here. One is the test result, one is the person's drug status. So let's focus on the result of the drug test. What would be the sample space for the drug test outcome? And that's going to be positive or negative. All right. Now, if you want to consider both variables together, right, there's also the person's drug status. So we could actually split this up into 4 different possible outcomes here, 4 different kind of categories. So if we wanted to do that, then the 4 results are going to be true positive, true negative, false positive, and false negative. And so that would be the sample space if our kind of variable of interest is kind of combining both together. If we're interested in both the person's drug test status as well as their personal status and how those things get kind of added together there. A couple other terms here. We have trial. So a trial would be kind of a like one process or one measurement. So in the drug testing example, each person taking a drug test was like one trial of that process. So you could say that we completed 555 trials. Now you do want to be careful with this term because the way we use it probabilistically may not always be the same way people use it in, say, medical studies, because oftentimes a trial is considered like one round of data collection. So we're not using that term in that sense here. We're using it in the term in this more in the sense of like a sample size, that we completed 555 drug tests. So just kind of keep those two ideas separate. Outcomes refer loosely to the individual possibilities in my sample space, right? So I have, 2 outcomes of the drug test, or we could also say that we have 4 outcomes if we're combining both the person's status, individual status, and their drug test result. So those are possible outcomes. Events are terms that we use if we're kind of thinking about how we might combine outcomes into like categories. So for example, getting an accurate drug test result could be an event that I'm interested in. And there's kind of 2 outcomes there that I could put there, right? So that would be true positive and true negative are 2 outcomes that fit inside that event of getting an accurate test result. So events give us more flexibility, and we're often going to use that term event when we're talking about assessing likelihood. We often notate an event with a letter. So like we'll say, let A be the event that Felicity gets an incorrect test result, right? So then A is going to kind of represent that event, and we'll talk about the probability of A being true or the probability of A not being true. Complement would be, or the complement of an event is going to be the scenario that event does not happen. It's going to be all the other outcomes that are not inside that particular event. So the complement of event A includes every possible outcome that is not already taken by A. So if we define A up here as the event that Felicity gets an incorrect test result, then the complement of A is going to be that Felicity gets a correct test result. It would be the true positive and true negative outcomes would be kind of the leftover ones not already included in A. And we use this notation of A with a little c to represent kind of the complement of A, like the leftover of A. So then the probability of A or A complement should be 100%. It should be that those 2 things should comprise all possible outcomes because it's everything in A and everything not in A. So we can kind of summarize that with a simple dice example. Let's say that I'm throwing just a 6-sided dice. There's 6 outcomes, 1, 2, 3, 4, 5, and 6. They're all equally likely. They all have a probability of about 1/6 of showing up. So then the probability that an event A does not happen is notated as A complement, and the probability of A complement is going to be 1 minus the probability of A and vice versa. All right, so let's start with this. We throw a die. If A is event of getting a 1, then A complement is the event of not getting a 1. What would be the sample space of A complement? Well, then the sample space of A complement, I'm just going to notate it like this. And that's going to be it's going to be everything besides 1. So I'm going to start at 2 and just kind of list the remaining outcomes. So if A is getting a 1, then A complement is getting 2, 3, 4, 5, or 6, any of the other remaining outcomes there. Now, what is the probability of A complement? So that's going to be the probability of getting a 2, 3, 4, 5, or 6. So I could think of it as I could just add up 1, 6 5 times, or I could also just do like 1 minus 1, 6. Either way, it works. I'll get the same amount. I'll get 5, 6. And if I want to round that as a decimal number, this is going to be 0.833 with repeating decimals. I won't continue writing them. I'll just round it to 0.833. I can also write it as a percentage. 83 to as many decimal places as I want. I'll just do 83.3% would be how I'd represent that as a percentage. I'll also just kind of mention this idea of calculating simple events. I'll kind of leave this for you, but just keep in mind that if you're working with equally likely outcomes, like we just did with dice, where 1, 2, 3, 4, 5, and 6 are all equally likely to take place, then I can calculate the probability of an event happening as the number of cases, the number of outcomes that fit that event, divided by the total number of cases or outcomes that are possible there, right? So if I'm looking at the probability of rolling an odd number on a 6-sided dice, and I know that all numbers are equally likely to take place, then I just have to count how many outcomes are an odd number, 1, 3, and 5. That's 3 outcomes out of 6 possible. So then the probability of rolling an odd is going to be 3 outcomes out of 6. And as long as they're all equally likely, that should work. If my outcomes are not equally likely, that isn't necessarily going to work. But we'll cross that bridge when we get there, and we'll talk about more kind of complicated situations. I'll also give you one more, but I won't do it for you here. Go back to the drug testing example. What is the probability that a randomly selected person in our sample received a positive test result? So you can kind of take a look at this scenario right here. I'll probably just kind of start here in class, but see if you can calculate the probability that a randomly selected person in our sample gets a positive test result.